Implicit differentiation. To find the derivative of y minus square root of y is equal to I in x, we first multiply each term with d over dx. So the first term is y minus square root of y will become y minus y raised to 1/2, and then the second term will become 1x because I in x is equivalent to 1 over x. Then we need to get the derivative of y minus y raised to 1/2. So it will become 1/2 y raised to 1/2 dy over dx equal to 1 over x. The next step, to isolate the dy over dx, we must cancel the term that has dy over dx. So it will become dy over dx times 1 over 2 square root of y equals 1 over x. So to cancel it, we must divide each term with 2 square root of y minus 1 over 2 square root of y. So the answer will become dy over dx is equal to 2 square root of y over 2x square root of y minus x. The next one is a higher order derivative. It refers to the derivative of a derivative. In calculus, the derivative measures the rate of change of a function at a particular point. The first derivative gives us information about the slope or rate of the change of function. When we take the derivative of a function multiple times, we get higher order derivatives. For example, the second derivative is the derivative of the first derivative, and it tells us about the rate of change of the change of the function. The third derivative is the derivative of the second derivative, and so on. Higher order derivatives can provide valuable information about the behavior and characteristic of a function. They can help us determine the concavity, inflection points, and other properties of a function. Like for instance, when we get the higher order derivative of the problem f of x is equal to e raised to negative x. So it will become f raised to n times x is equal to negative 1 raised to n times e raised to negative x. So it will become f double prime x is equal to negative 1 raised to 2x e negative x. Then to simplify, we get e raised to negative x. So the higher order derivative of f of x is equal to negative x is equal to e raised to negative x. Maxima and minima are the highest and lowest values of a function, respectively. They represent the peaks and valleys of a function's graph. A maximum occurs when the function reaches its highest point, while a minimum occurs when the function reaches its lowest point. Maxima and minima can be local, highest or lowest in a small neighborhood, or global highest or lowest in the entire domain of the function. Finding maxima and minima is important in optimization problems in calculus. Techniques such as finding critical points and analyzing concavity are used to determine them. Not all functions have maxima and minima, and their behavior depends on the specific function and its properties. For example, the cost C of a product is a function of the quality x of the product. C of x is equal to x squared minus 4000x plus 50. Now we get to find the quantity for which the cost is minimum. So there are 4 choices. The first one is 1000, B 1500, C is 2000, and D is 300. To look for the answers, there is a solution. C is equal to x squared minus 4000x plus 50. Now, we need to get the derivative of x squared, which is 2x. Then the derivative of negative 4000x is 4000. Then the derivative of 50 is 0, since it's constant. To get the x, we need to transfer the 2x before the equal to isolate the x, and divide both sides by 2 to cancel the 2 to become it x only. So the answer will become 2000 units. So the correct answer will be letter C, 2000. The last one is time rate. It is also known as rate of change with respect to time, referred to how quantity changes over time. It measures the rate at which a variable or quantity is changing with respect to time. Let's say, for example, two railroad tracks are perpendicular to each other. At 12 p.m., there is a train at each track, approaching the crossing at 50 km per hour. One being 100 km and the other 150 km away from the crossing. How fast in km per hour is the distance between the two trains charging at 4 p.m.? We have four choices. The first one is 67.08, B 68.08, C 69.08, and D is 70.0. Now we must find out. To solve for the answer, the first step is S squared is equal to 50t minus 100 squared plus 50t minus 150 squared. Now you must get the derivative of all the terms. So the derivative of S squared is 2s times ds over dt, and the derivative is equal to 2 times 50t minus 100 times 50 plus 2 times 50 minus 150 times 50. Then 2s times ds over dt is equal to 2 times 50t minus 100 times 50 plus 2 times 50t minus 150 times 50 all over 2s. So the 2 will be cancelled, so it will only become ds over dt is equal to 50t minus 100 times 50 plus 50t minus 150 times 50 all over s. When t is equal to 4 hours, s squared is equal to 50 times 4 minus 100 squared plus 50 times 4 minus 150 squared. So the s squared will become 12,500 and it will become 111.8 kilometer. To get to the answer, we must substitute s, so it becomes 111.8 and t is equal to 4 in 1. So ds over dt will be equal to 50 times 4 minus 100 times 50 plus 50 times 4 minus 150 times 50 all over 111.8. So the answer will be 67.08 km per hour. So the correct answer will be letter A. And that will be all. Thank you.